Today I'm going to be teaching you how to factor and expand linear expressions. In order to be successful at this skill, you need to have a good memory of how to find the greatest common factor of any two terms or numbers, and you need to know your distributive property. Okay, all of these things you should be familiar with, but if you've forgotten, you should really go back and review those two concepts before you move forward. Okay, so let's go ahead and take a look here at the notes, and I'm just going to scroll up here. Okay, let's talk about how this might play into the real world. Real world link, yard sale. A rectangular yard is being separated into 4 equal-sized sections for different items at a yard sale. The area of the yard is 8x plus 12 square meters. You're probably thinking, why would the area of the yard be 8x plus 12? Well, go with me. This is like, if you didn't know, we're going to use an algebraic expression to set this up. So the area itself is 8x plus 12, and we want to split this into 4 equal-sized sections. So how could you find the area of each section of the yard? Well, since there are 4 sections, you could divide the total area by 4. So let me write that down. You go ahead and write with me. Since there are 4 sections, divide, sorry, that handwriting is really messy. Divide 8x plus 12 by 4. Okay, so if you were to do that, what is the area of each section? Well, the area of the expression, if you were to divide by 4, well, think about it. Do 8x divided by 4? That would be 2x. 12 divided by 4 equals 3, right? So if you were to use your distributive property and what you remember, 4 multiplied by any number is the next, so like 4 times 2x is 8x and 4 times 3 is 12, you could have 4 times 2x plus 3, and that would equal the original expression, right? If you think of your distributive property, 4 times 2x is 8x, 4 times 3 is 12. Those are the same thing, right? It's just 2 different ways to write the same thing. So the area of each section would be 2x plus 3. That would be each section, because we made 4 of them. You can also use algeblocks to help you to find the area of a given expression. Okay, so look at the situation that we have down here. If you look, this is a rectangle, right? This right here is a rectangle. The width of the rectangle is right here. This is the width. It is 1, 2, 3, 4, right? 4, there's 4 of them, 4 x's, right? Or 4 green cubes. Over here, we have our length. I like to actually think of the width. If I looked over here, there's 4 green cubes. Remember, our algebra blocks that we have are a little bit different than this book. Our algebra blocks are for the green cubes represent 1. Here they use yellow cubes, but imagine these would be our green cubes. And our x's look like french fries, so they would be yellow. So here, our length, which is right here, that's the length, it would be 2x plus 3. A lot of people, when they look at this rectangle, would say, oh, the length is 5, because I can see there's 1, 2, 3, 4, 5, but it's not 5 cubes. We know from our algebra blocks that each of these is x, so that's 1x plus 1x is 2x, and 1, 2, 3 is 3. So when you're doing some of your practice work in the C step, you will be asked to use algebra blocks to model algebraic expressions. When you have to set them up into rectangles, you need them to look like this, where you have even rows and columns, okay? Go ahead and go to your next page. Okay, a couple of things we need to know, a couple terms that are going to come up, and you'll see them in some of your practice work. Okay, let me A monomial, okay, this is a word we have not seen, is a number, a variable, or a product of a number and one or more variables. So a monomial is like either 25 is a monomial, x is a monomial, 40x is a monomial. These are not examples of monomials because they are not products. X plus 4 and 40x plus 12, those are expressions, but they're not monomials. Okay, to factor a number means to write it as a product of its factors, or to divide out a common factor is what I like to think. A monomial can be factored using the same method you would use to factor a number. That means you can use your greatest common factor. Okay, the greatest common factor of two monomials is the greatest monomial that is a factor of both. That is simply saying use your GCF method. Now, I think you should always use your cake method. It is so much easier, and you guys are really good at it. So that is what I will be using to show this. Okay, so I'm going to do off to the side exactly what they've done here. So it says, find the GCF of each pair of monomials. So 4x and 12x. I'm going to put them in the cake, and I'm going to factor them. Okay? So the first thing I'm going to look at is what goes into 4 and 12? Well, 4 does, right? But let's start with 2, just to show you the long way. So 2 goes into 4x. 2x times. Don't forget the x. It's part of the monomial. 2 goes into 12x, 6x times. Again, don't forget the x. Now, is that factored? I don't think so. You should see that you have 2 and 6. Those are both still even numbers, so you should divide one more time by 2. Then you're left with x and 3x, right? So now, the one problem I have here is there's still this x that's in common. I think we should pull that out, right? Okay, because that is also part of the factor, part of the greatest common factor, because there's still 2 of them. So if we take out the x, we are left with x divided by x is 1. 3x divided by x is simply 3. So now, what is the GCF? You should remember from your cake method, 2 times 2 times x. That's your GCF. So your GCF is 4x. That's the GCF. You can see over here they used the listing method, or they did what's called prime factorization. We don't really do that. It's just more difficult. But they found the same answer that we did using the cake method. Trust me on this. The cake is way better. Okay, let's do another one. I might have to add a little bit more room to do another one. Let's move this up a little bit. Let's do 18a and 20ab. 18a, 20ab. Okay? What do you think the common factor is of 18 and 20? Well, I know for sure 2 goes into them. I also see that there is an a in common in both. So I'm going to go ahead and take that out too. So how many times does 2a go into 18a? Well, I think that is 9, because now you always know if you're correct if you multiply. Like 2a times 9 is 18a. That should be correct. Okay, 2a goes into 20ab. That's going to be 10b. You took the a out. You took the a out over here, so you can't leave it in down here. You took it out. Because remember, you have to take this times this should equal this. So 2a times 10b would be 20ab. So our greatest common factor, because this cannot be factored anymore, 9 and 10b have nothing in common. So our greatest common factor is simply 2a, which is what they found. Let's do one more. 12cd and 36cd. Okay, what are the greatest common factors of those two monomials? Well, I see that there's a 12 and a 36, so I think 6 would be a good idea to start with. 6 goes into 12 2 times, and into 36 6 times. Don't forget the CDs, but I can see that they both have CD, so I should probably take that out this next time. So I'm going to take 2 CD out, and I am left with 1 here, and 2 CD goes into 6 CD 3 times. So my greatest common factor would be 12 CD, and that is exactly what they got. Okay, now I would like you to pause, and I would like you to solve this problem this problem, this problem. Please add a page and find the GCF of these three monomials. Okay, when you come back, I will give you the answers. Okay, so pause for now and please complete those three problems. Please come and show your teacher in the middle of your notes what you got for those answers. Actually, yeah, instead of me putting the answer in the video, I think this is a good time for me to see how well you're listening. So instead, come to your teacher and show the three answers. Or actually what we'll do is we'll put these three questions into your note check. Okay, go ahead and go to your next page. Okay, this is just simply the same page again, so I'm going to kind of scroll over here and put this one right here. Okay, you can use the distributive property and the work backwards strategy to express a linear expression as a product of its factors. A linear expression is in factored form when it is expressed as the product of its factors. So for example, let's show that. If I had 8x plus 4y, now it's an expression with two monomials in it. We can still use our same method of finding the GCF using the cake to do this. Okay? What goes into 8x and 4y? Well, hopefully you're saying 4. 4 goes into 8x 2x times, and into 4y simply 1 time, or y. You can tell that you're correct, again, because 4 times 2x is 8x. 4 times y is 4y. So our GCF is 4. The way we would write the factored version of the expression is 4 times the bottom layer of the cake. 4 times 2x plus y. That's your factored form. Factored. Okay, you always can check these to know if you're right, because you can use your distributive property. 4 times 2x is 8x. 4 times y is 4y. That is called expanding, okay? Expanding the expression using the GCF. Okay. Let's do another one. Let's do this one, 3x plus 9. So you can use your algebra blocks to do this if you like. They show you there with the rectangle, which you will do. I'll show you that as well. Or you can use your cake method. So let's look at the algebra block way first. Whoops, I didn't want to do that. Sorry. If you look at the algebra block way, they have set up 3x and 9 cubes here, right? So the width of the rectangle is 3. You can see that right here. The length is x plus 1, 2, 3, x plus 3. So our factored version would be 3 times x plus 3. I will show you over here using the cake method. Divide out the common factor, which is 3. 3 goes into 3x 1 time, or x times. 3 goes into 9 3 times. So our GCF is 3. This is our factored version, or our remaining factors. So you take 3 times x plus 3, and you are left with this factored version of the expression. If you were to expand, 3 times x is 3x, 3 times 3 is 9. That is correct. And you can see that they have the same answer right here. Okay, let's do one more. 12x plus 7y. Okay, let's see if I can make some more space here. No, it's not going to let me do that. There we go. 12x plus 7y. Do you see anything that those numbers have in common? Personally, I do not. There is not one single thing that is a common factor of 12 and 7 or x and y. So the greatest common factor is simply 1. So this is already in factored form. So the factored version is simply 12x plus 7y. Or some people say it cannot be factored. You can use either way. Okay, I would like you to do these 3 problems. These 3 problems will also be part of your note check. Okay? Use your cake method to do both. One thing I'd like you to pay close attention to is that this one right here has a minus sign instead of a plus. So when you write out your factored version, you should have a minus instead of a plus in the middle. Okay? Actually, no, I think I'm good. I will have you do those as your note check. Okay, go ahead and go to the next page. Okay, The last thing I want to show you is another real-world example. The drawing of the garden at the right has a total area of 15x plus 18 feet. Find the possible dimensions of the garden. What that is simply asking you is to factor 15x plus 18. That's all the question is asking in math terms. So let's draw our cake and let's factor it, okay? What goes into 15x and 18? Well, 3. 3 goes into 15x 5x times. Bring down your plus sign. 3 goes into 18 6 times. Can this be factored? No, that's as factored as it can get. So our GCF is 3. So we would write the factored version, 3 times 5x plus 6. You can always check to see if you're correct by expanding. 3 times 5x is 15x. 3 times 6 is 18. So the possible dimensions are 3 feet by 5x plus 6 feet. You do not need to do this as your notes because this is actually the practice activity. So I'm just going to kind of cross this out. But I do want you to do one thing for me. In your notes, I would like you to rate yourself. Are you ready to move on? Answer yes or no. Okay, and please show that to your teachers when you show your notes. Before we move on, though, one more time, and actually before you rate yourself, go to the next page, and I want to show you one more example of something. The one thing we didn't specifically talk about was expanding, okay? So expanding is simply using the distributive property. Okay, so I'm going to write expanding. You can add or use the page that you have in your notes packet for this. This is distributive. I'm going to show you a couple of things. You might be given a problem or an expression that looks like this. 1/4 times 4s plus 8y. And it might say expand. Okay, so what you need to think about is using your distributive property. Okay, 1/4 times 4s. So the way it would be the way it works with the distributive property is you times it by each individual factor. Hopefully this is starting to ring a bell with you or cause you to think back to Unit 2 if you're in the regular classes where we did the distributive property. Now, you could leave it like this, but since you can still multiply, you should. So 1/4 times 4, hopefully you have remembered how to multiply fractions. If you've forgotten, please go back to your fraction unit. Okay, for advanced, that's Unit 1. For regular, that's Unit 3. With a whole number, you always add a 1 underneath. Okay, so 1/4 times 4 over 1, cross simplify. And you are left with just simply 1, which would mean 1 times s, which is simply s. Okay, 1/4 times 8y. I'm going to carry my plus sign all the way down so I don't lose it. 1/4 times 8 over 1, cross simplify. You would end up with 2 times y. Okay, so hopefully you see how that happened. So s plus 2y is the expanded version of that. Okay, let's add one more page and just so I can show you something just a slightly easier. That was a fraction one, which isn't too difficult, but still, just let me show you what it would look like if it wasn't fractions. Let's do one more example. Like, let's say you have 5 times 3y plus 7z. To expand it, you simply use your distributive property. This would be 5 times 3y. Let's change this to a minus just so you get to see what it looks like with a minus. Okay, minus 5 times 7z. Combine these here or multiply. This would be 15y minus 35z. If you are in our advanced classes, please keep in mind that sometimes you may be given negatives. If you're in my advanced classes or in our advanced classes, please go to one more page and take one more example. If you are in the regular classes, you may stop here and go on to the note check. One more example for the advanced students. Let's do a negative. What if I have negative 4z times let's say, negative 5p minus or plus 3z. Let's say, and it said to expand. If we expand, we would get negative 4z times negative 5p plus negative 4z times 3z. Go ahead and combine here. Negative times negative, bad guy leaving town, that's a good thing. So you would have 20zp, and over here you would have a negative times a negative, so this would be plus negative 12z squared, because z times z is z squared. But do we like double signs? I don't think so. Adding sand is the same thing. That makes something go down as just taking away gas. So you should write this as 20zp minus 12z squared. Okay, hopefully this helps clarify what factoring and expanding means. Please go ahead and go to your note check where you will be asked to answer those practice questions that were listed in the notes packet. If you have any questions, please feel free to ask your teachers. Bye for now.